In Chapter 24, we had a relationship for the relationship between the charge and the potential of charge and potential with a capacitor. And that was just Q equals C times V. Well, there's another relationship called Ohm's law that it deals with the relationship between current and potential. And that relationship is potential is equal to current times resistance. So we have this value of R, resistance, and it's related to a current flow. So let's draw a symbol. And the best way to draw a symbol that looks like a resistance is to draw a squiggly line here. And this is our resistor R. And we have a current I. Now there is a proper terminology, and I'm going to put this such as, so you can see what I'm doing here. This is point A and point B. There is a potential between point A and point B. So the correct terminology, and I will correct you, is current flows, I'm going to capitalize it, through a device. It's never across a device. So current always flows through. That's the correct terminology. We should always say current is flowing through a device. Now, for the potential, is, I didn't spell potential correctly. Potential is across a device. It is never said to flow through a device. And students will tend to get this messed up, and even engineers will tend to get this messed up. And it's just good to have the correct terminology when you're talking to any engineer. If you ever go on a job interview, they're going to look to see if you're right, using the right terminology. So the current flows through, the potential is across. So what this formula is saying is that if I have a current flowing through a resistor, through some device that has some resistance to the flow of current, it's going to take a certain amount of work to get that current through the resistor. Now, resistors are actual devices, actual parts that come in different shapes. You can have a carbon resistor, and you might see a shape something similar to this. If I can draw good here. Sometimes they're like that, or it may just be a cylinder. You could have sand block. And those usually are pretty big. There'll be a rectangle or a box, something like so. You could have wire wound. Typically those are in a cylinder that's hollow, and you'll have leads coming out like so. And there are other types. Now, for carbon resistors especially, there is a way of telling the value of the resistor. And there's a table in the notes and in the book for a resistor. And you're going to have different bands across the resistor. And it's going to look something similar to this. And the band that's closest to one of the ends is the one you're going to start with when you go to make your measurements. Now, the book, he basically just shows a 4-band resistor. There are a number of different types. It has to do um, with the amount of um, tolerance and also how close you want the resistance values. You can have 4, 5, 6. There's websites that have resistor calculators on it that you can use. So when you have a resistor, the first band is your first digit. The second color is your second digit. The third band is your multiplier. And the fourth band is your tolerance. Now in the book you have a list of the bands. So you have a color and a value. And if you want to do the multiplier and the tolerance. So you have, start with black, brown, red, orange, yellow, green, blue, violet, and then I think I ran out of space here, so I'll have to start it on the next page. So from violet, we have gray and white. And then for tolerance bands, we have gold, silver, and none, or no color. For the value, we start with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. For the multipliers, we have 10 to the 0, 10 to the first, 10 to the second, 10 to the third, 10 to the fourth, 10 to the fifth, 10 to the sixth, 10 to the seventh, 10 to the eighth, 10 to the ninth. Usually rarely find those. And then you can have gold, which is 10 to the minus 1, and silver is 10 to the minus 2. Now, for tolerances, brown is 1%, red is 2%, and then they skip to gold, and gold is 5%, silver is 10%, and no band or no color is 20%. So in the case of this resistor, we have red, so red is 2. We have blue, blue is 6. We have the multiplier is orange, so that's 10 to the third. And the tolerance is silver, so that's 10%. So the value of our resistor is 26,000. Ohms is the unit, capital Omega, plus or minus 10%. Well, if it's plus or minus 10%, then the range is going to be 26,000 minus 2,600. So that's going to be, let's see if I can do my math here. It's going to be 0, 0, 4, and that's going to be 23,400 ohms. And our top range is going to be that's going to be 28,600 ohms. So what this means is that this resistor is guaranteed to fall within this range. That's how the tolerance works. Now, if you have a hard time remembering the order of the colors, here's a quick little ditty that we came up with years ago that helps if you can remember, and if you enjoy alcohol, you'll probably really like this. We have bad beer, rots our young guts, but vodka goes well. Bad beer rots our young guts, but vodka goes well. So some people have a way of remembering that one instead of trying to remember the order of the colors. For gold, silver, and no color, well, you're on your own for that. But this is how you read resistance values, and you'll be doing this, you'll be needing this for one of your labs, or actually three of your labs. You're going to need to be able to read these resistance values off of the bands for your labs.